Alright, ready, set, and go. Alright, first we're going to be attaching the flaps to the drum. I don't need any of this. Take a couple of these. How does this work?
Alright, here's a little bit of a director's cut of this assembly process. It's a full 14-minute video, so if you just want a bit of a closer look at how one of these modules is put together, you can take a look at this video. I'll do a little bit of voiceover over it. So here I'm attaching all the flaps to the drum, 64 flaps. Some people thought these were stickers on these flaps, but these are actually fully 3D printed. So I designed the flaps to have these letters and characters embedded in them, and they're printed as one piece using the Bamboo AMS multi-material printing. So it prints, I'm using PETG for all of this, but it's printing first the white text, and then the black plastic, and then it does basically 3 layers. The first layer, the middle layer of all black, and then the top layer, which is the other side of the other letter. So they're all printed, all 64 flaps are printed on one build plate at a time, and so for the whole thing it took 45 prints. Each one of those took about 2 hours, but that's kind of how the flaps are made. Oh, also the colored flaps are actually just a vinyl sticker. I think I got a Cricut vinyl cutter sheet, but I don't actually own a Cricut, so I just cut them out with scissors and stuck them to each of the flaps. The making of the drums with all the flaps included is probably the lengthiest part of the project, just because of how many prints it entailed. I could get a lot of drums on one print bed, maybe I think 9 at a time, but like I said, each of the flaps was its own print, and so for a little while I could do like maybe 2 a day if I was working from home, but definitely took a while to print all of them. Other than that, I mean, all the enclosures took a while, and it went through a couple design iterations during the actual video, so I printed like 10 of them, and then changed the design a little bit and had to reprint. So a little bit of wasted enclosures there, but in the end, I mean, all of the printing must have been hundreds of hours. I probably could add it all up, but I never bothered to add it all up, but it took a long time. I kind of touched on this in the video, but this isn't actually how I built any of them. Putting all the materials out like this and making them, one at a time. I kind of batched the processes out, so I made, I don't know, maybe 10 or 15 at a time, and I would do all the soldering of the pogo pins and attaching to the DIN rail mount piece. And then, separately, I made all of these drums for 10 or 15 modules at a time. I would sit down and watch TV and attach all the stickers for the colored flaps. So I would batch the processes out. I would really sit down with all the parts for one module and make one at a time. Another thing about these flaps is they had to be printed just with a slightly special print profile. I think I just used a 0.4 millimeter nozzle like normal, but instead of 0.2 millimeter layers, they were 0.16 millimeter layers, and that's just because the flap thickness evenly divided into 3 0.16 millimeter layers. So I just had to make sure that the first layer was also 0.16 millimeter, or else they'd be a little too thick to fit into the holes. And here's the last flaps coming together. Nice. There we go.
Next step.
Now we gotta solder the pogo pins onto here. I use the DIN rail mounts as a sort of guide for where the pogo pins go. I didn't want to have to you know, solder the pogo pins in and then have them fit into the DIN rail. Fit into the DIN rail mount. So I put the pogo pins in the little holes here, and then attach the board to it and solder directly there, so it fit. I never really had to take it out, so I never like dealt with a board that just had pogo pins sticking out the back without the protection of the plastic. I know someone said that I could get like surface mount pogo pins assembled by, you know, the manufacturing company, and that might have worked fine. I'm sure they know what they're doing, but I was worried about them breaking off, so I just figured I'd solder them myself. Another question a lot of people had is how I addressed each module, how I, you know, sent commands and each module knew which letter to go to. The way I did that was just hard coding the module ID in code. There probably was several better ways I could have done it. I mean, people suggested passing packets between them, but I didn't want to have to worry about, you know, connecting each of them to each other. I just wanted to connect all of them to one shared signal line. And, you know, hard coding the module ID I figured was the easiest solution, and it works well for me. I mean, I can't...
All right, next.
I'll let myself talk. Okay.
No.
I can't necessarily put each module in any random place. They need to go in a specific spot on the board, but I didn't figure that was that big of a deal. And if I ever needed to replace a specific module, I can always, you know, reprogram it to be, you know, whichever module ID I need. So yeah, that's how it works. Basically, the Raspberry Pi sends signal over the RS-485 line, and it sends a signal in a long sequence that says like module 0, go to A, module 1,
Missing
go to
bolts.
B, module 2, go to C, etc. And it sends that one after another, and that's how each module knows how to do it. And it's not that fast of a signal. That's why, like, when I first, well, okay, two things. When I first turn it on, and you notice like it kind of taking a little bit of time between each one and going like that, that's because I programmed a variable amount of delay based on module ID to start the homing sequence, and that's just so there's not a
insert our
big...
motor.
Sorry, I'm talking over myself. That's just so there's not a big current spike on the power supply by them all starting their homing sequence right at the same time, right when you turn it on. But
Easy.
when you actually send a command to it, like when I wrote hello YouTube or whatever, it sends them one after another, and there's a little bit of a delay, maybe 10 milliseconds or 20 milliseconds between each one, and that's why you can see sort of like it cascading down the line. But I kind of like the look of that, so I didn't figure it was that big of a deal. I could have, you know, potentially added something on the software side that tells it to calculate how long it's going to take to get to the specified letter, and then, you know, wait a certain amount of time so that they all arrive there at the same time. And I still might do that, you know, just in the future, but I didn't bother doing that for this video.
Sensor.
Okay, in this video I'm attaching the Hall effect sensor here.
Clip.
A specific thing about the Hall effect sensors was that, you know, soldering the wires, the JST connector wires onto the Hall effect sensor was a pretty tedious process, and in the Onshape file I designed a little template to, you know, put a Hall sensor into and put the 3 wires into so that you can solder them easier. So if you're ever doing this yourself, I would recommend going that route. Yeah, that's it was fairly tedious, but it was not too bad. Also, small
on the
thing,
next step already.
but I did most of this with an electric screwdriver, not just this Allen wrench. That definitely saved a lot of screwing. The wires here are a little bit long, but I figured on a couple modules I tried to cut them shorter and ended up cutting them too short. I figured a little long was better than too short, and that's why I just kind of like pile them in there and twist them in a specific way to fit in there nicely. It's really not too hard to get them fit. There's plenty of space in the back of that module there. There's 3 bolt types, I think, in this module. There's these little ones that I'm attaching the DIN rail mount to, and I think those are, well, they're all N3, but those are either 6 or 8 millimeter. I can't quite remember. And then there's 30 millimeter bolts that attach that gear plate through the back, and then 40 millimeter bolts that attach the top cover on. So I tried to keep it minimal, but I needed
this. My time's all messed up.
I needed 3 different. I messed up the timing when I was doing the speedrun thing, but I figured it wasn't that big of a deal. But yeah, anyway, I tried to keep it minimal, but I still needed 3 different bolts for this, unfortunately. But it wasn't so bad because if you're making 45 modules, you need so many of them that it's not that big of a deal to have to buy different ones.
Trauma solved. Bam.
One thing that may not be entirely obvious, not all these bolts are integral to the design, but one that is actually that the one that's kind of on the bottom, not the one that has the nut in there right now, but the one that doesn't on the front. I'll tell you when I'm inserting it. But that bolt specifically, the flaps, when they flip down, rest against this one that I'm inserting right now is what I'm talking about. Yeah, this one. The flaps, when they flip down, rest on this bolt and kind of form like a hard surface for the flaps to, the new flap, the next flap, to flip onto, and it kind of makes that iconic split flap noise. It makes it more apparent. If you didn't have that bolt there, the flaps kind of just like float in the bottom and can flip back and forth a little bit easier, and the sound is a little bit muted because of that. So maybe in the future some improvements might remove some of these bolts, but that one's actually necessary because it causes the sound to be that iconic split flap sound. Alright, as I'm finishing up this build here, I hope it gave you a little bit more insight if you're looking to make this as to how it came together. I know a lot of you are looking for some sort of actual tutorial.
Oh no, I didn't print a label.
This was trying to print a label in the process too. I forgot to have one. Yeah, I know a lot of you are looking for like an actual tutorial how to make this. It's a little bit, it's harder than you think to make an actual tutorial, and not to mention you'd have to order the PCBs for yourself. So I'm thinking about it. I'm thinking about how I might do this, but for the moment I don't have a tutorial available, and it might be a few weeks or a few months before I have one available, and I'm really sorry about that. But I did want to provide the files in case you wanted to parse through them yourselves and try to figure out how to make it. Feel free to ask any questions. I'm happy to answer as much as I can, but I just don't know if I can provide a full tutorial at this moment because I do have a full-time job, and I want to work on some other videos and other projects in the future too. So anyway, thank you guys for your support. I really appreciate it. This took off way more than I could have ever imagined. I never expected to get this many Patreons or this many people interested in the project, not to mention views and subscribers and things like that. So I'm looking forward to making more projects in the future, but I've been working on this one for the past 6 months, and I'm looking forward to putting it aside for now. Maybe I'll revisit it in the future too. But anyway, thanks for the support. I hope you continue to watch. I hope my next video is good. Let me know if you have any ideas of what I should work on next. I'm still working on the ideation process. But anyway, thanks y'all. I hope you enjoyed this little behind the scenes bonus content video.
Done. All right.